back to the Green Connection. We've run all kinds of things. We sort of tipped the scale from building green, living sustainably, and today we're going to go to rocket science. I began hearing about all the rockets that are taking off to space, the manufacturers that are doing manufacturing and liftoffs in Texas. And so I began looking up what rockets they're doing in San Antonio, and ran across Colin Lang, who is a rocketry teacher at Elmo Heights High School, and he has a program that takes students, and it's a voluntary thing. Students join the group. It's, do you have a name for the group?
It's called Systems Go.
The what?
Systems Go.
Oh, System Go.
Yep.
And one of the unique things is the group that he had, was it this year's group that went to White Sands?
Last year's group went to White Sands.
Well,
they're getting ready to go to White Sands.
Oh, they're getting ready to go
Yep.
to White Sands. Last February, I believe, kind of a unique thing happened. UTSA has a club called ARC, which is the Aeronautics and Rocket Club. And they decided that they would look at high school rocket programs or just school programs and partner with the high schools to design payload for their big rocket, which is very unique. That in itself, Colin, is something that is happening, I think, where schools are partnering in various things instead of being all separate.
Yeah, it's the connection with UTSA. My former student Eric actually was the one who began that program at UTSA, and Eric is now an engineer at NASA at Johnson Space Center.
And one in Houston, or?
He's in Houston, yes.
Yeah, I was there when that was built. That was a rice field in the beginning. So anyway, what the students, with the competition.
At the college level, it is a competition. Our level is not a competition. We're not trying to compete against other schools. What we're trying to do is actually help each other so that we grow as a country and progress forward as a country. Our competition's all the other countries, so to speak.
But the partnership with UTSA was a competition.
Correct.
And it was to design the payload for the rocket. What is the payload?
I'm not sure what they ended up doing with that one. Our payload this year for our rocket that we're going to be taking to White Sands is going to be they created like a black box, so to speak, and we're going to have components and electronics in that. They're creating like a computer system that's going to be able to sample air pressure, temperature in the combustion chamber, our nitrous oxide tank pressure, and different things like that. So we can take that data and learn from it, because it doesn't really exist for the type of motor we use.
So you're going to do a repeat performance?
Correct.
We have a video showing the White Sands liftoff from last year. It was June 20. Well, it was in June.
It was in June, yes.
Of last year, and it'll be in June this year also.
I hope so. Yes.
So let's look at the video and see exactly what these students do.
On June 25th and 26th, White Sands Missile Range and the Systems Go program conducted the Systems Go Goddard launch event, where students are able to launch a rocket that they built from the ground up.
We set up the rocket on stands, we assembled everything, got it flight ready, and then put it on the rail.
Students from Brazel Woods High School near Houston, Texas, Alamo Heights High School in San Antonio, Texas, and Union Grove High School in Gladewater, Texas, participated.
This morning we were the first ones out to launch, so we came here, we sat in the bunker, we waited and we waited, like the phrase always says, we hurried up and waited. And it looks like from the initial data that the students may have gone about 36,000 feet, which would be a record for the program.
3, 2, 1, fire.
We got to actually launch the rocket that we spent a whole year working on, whether it was technical work or actually hands-on manufacturing. We have all put in a lot of work into this, and we've done all of our research on it. So the best we can do is hope that it flew well, and it did. So I started off nauseous, and then I started feeling giddy, and then realization kicked in that my work actually worked, and so now I'm just pretty happy.
White Sands Missile Range has been involved with Systems Go for around 23 years, promoting engineering studies and research by providing real-world opportunities for students.
We had a successful takeoff. We got off the rail very well. We had a takeoff sequence that was, I think, pretty much what we expected. It took about 2 seconds from ignition to get us off the rail, and that's what we about predicted. So we do not know exactly how high the rocket went, but we're pretty confident that it went to at least a record for our school, because we've gone to about 24,000 feet. And the radar, even if it didn't have the right start-off altitude value or something like that, it kept climbing for at least 24,000 feet. The moment that it actually took off, it felt really good, because I forgot about the 2 seconds that it was going to be burning before it went off, and it kind of scared me. I was like, is it gonna leave? But once it took off, I was just focused, because I was wanting to look at the computer screen and give call outs to the team about altitudes and everything, and that was a really fun thing.
There's a lot of people who are concerned with the future. They say that the next generation is gonna, ruin America, ruin this, but I work with the best problem solvers, the best team workers, and the best students that I've ever seen. So the future's in good hands with this crew.
We have some of these students from Alamo Heights, which Colin has brought with him, that have worked on these projects. It's a volunteer.
It's a 4-year program. It's a class, so they do get some science credit and elective credit for the classes that they take.
And then what you say, mostly juniors? Are they juniors?
It's a 4-year program, so
Oh.
I've got freshmen, sophomore, juniors, and seniors.
Open to all.
Yes, and each year is like a progression from like simpler things to more complex. The freshman level, they learn how to do AutoCAD, so they learn how to do mechanical drawings. There's kind of a datum that's stable, and that is if you can't draw it, you can't build it. So I teach them the same kind of AutoCAD program that they would get in a college. And so from there, the new pathway is sophomores are going to come in, and they're going to build a rocket similar to this one that will carry a 1-pound payload to a mile-high altitude. Their junior year, they come back and build another one similar to this, and that one's designed to go to Mach 1 or better, but at an altitude of 13,000 feet. And then their senior year, historically, what we've done is we've gone to White Sands, and that rocket is usually around 25 feet tall, weighing in about 400 to 600 pounds, and those are designed to go to 100,000 feet at better than Mach 3.
That gives them a goal, more or less.
Correct. And it's, to put it into perspective, most colleges, what they do their senior year for their senior capstone project in aerospace engineering, we do as juniors in high school. So it's quite the opportunity that they're getting.
How many schools include a rocket program?
Well, the Systems Go program now, it began in Fredericksburg with a gentleman by the name of Brett Williams, and he saw a need that we weren't, first of all, producing very many engineers, and the ones we were producing couldn't seem to engineer. So he decided to start this program out in Fredericksburg High School, so there was only the one school. I came on board at the first group that he started training so that they could have other schools doing it. And now there's about a total of, I believe, more than 60 schools across Texas, some in New Mexico, and I think there's one in Utah and in Colorado now too. And so the program is growing. It's taken a long time to get to this point. There's only 8 schools that do what we do, though, doing the high altitude rockets
You mean
at White Sands.
nationwide? Or?
Nationwide, yep. only 8 schools. And the very best that we've been able to achieve so far is 35,000 feet at about Mach 2.
So, do you think that rocket building and the rocket industry could make San Antonio Rocket City?
Yeah, absolutely. And we have the folks who can work in those places. We're situated in a really good location in terms of geography. With White's, Virgin Galactic, and we've got guys help me out. SpaceX, Boeing, Blue Horizon, all of those folks now that are becoming very competitive, and they need engineers. And so this is a great opportunity for our kids now to fill those positions.
So what it is, it opens up opportunities,
Correct.
a whole new era for jobs.
Yes, and there was no real competition before. NASA was the only place that you could go to build a rocket that was going into space, and now with all of these other companies opening up, the competition is breeding a great deal more innovation too. So you look at the rockets that SpaceX is building, they're very advanced, and the idea of being able to reuse them and landing by themselves autonomously, it's amazing.
Well, and pretty soon it'll be like, not pretty soon, but soon, it'll be like an airport.
Mm-hmm. Yeah, with Virgin Galactic doing what they're doing with space tourism, and Blue Horizons with space tourism, it's more and more people are going to get the opportunity to go to space.
And I read the other day that there's a company that is designing houses to build on the moon.
Yeah, there's one that actually has a space hotel that's orbiting the Earth right now. Bigelow Industries is the name of that company, and so the idea is like very similar to being on the space station. You can be a space tourist and go and stay in their space hotel orbiting the Earth.
Fly me to the moon.
Yes.
You brought some students with you.
I did.
And we have 7 of them. And they're all wearing your team shirt, except we have a blue lady. And it's interesting, we have girls that are in these programs all
Correct.
the time.
Yeah. Young ladies make fantastic engineers. One of my favorite stories is a young lady by the name of Julia who accidentally kind of took my course because she heard it was an easy A and the boys would build the rocket for her. And she told her science teacher that year, a chemistry teacher, that she hated math and science and that she was going to do the absolute minimum to get by. And then she would never think about math and science again once she graduated from high school. And now she has a PhD in planetary and earth sciences. So, yeah.
So the women are a part of the...
Absolutely. Yes.
That's great. Okay, would you like to introduce your students?
Sure. We'll start with Eric. Eric is our project manager this year. All of these students are seniors, and so pretty much all of them have been with the program now going on 4 years. But Eric was voted by his peers as our project manager, and so he's going to tell you a little bit about some of the technology that we're using in the rockets.
All right. So right here we have our propulsion system. And so how this works is we fill this tank right here with nitrous oxide, which is our oxidizer, which then gets pushed here into our injector, which helps put the nitrous oxide into a gaseous state. And this goes into our what we call our fuel grain. And this is filled with oxygen that burns to help preheat it. And so when the nitrous oxide goes into this, it starts burning away at the plastic inside here, which then comes out here from our nozzle, which then propels one of the rockets here, which you see with the purple tip, to the speed of sound or greater. Now, for our bigger rockets, what we do is we build this all from scratch. So we build a tank that is about 9 times the size of this into something that's 9 times the size of this, which then propels a big rocket to 50,000 feet, which is our goal for this year. And hopefully as a team, we can accomplish that because I'm fairly confident this year that we have a really strong team.
So the motor that is there, that's a commercially purchased one, right?
Yes.
And those we use for which level of the program?
We use these for our level 3 or junior rocketry class for our transonic rockets right here, which goes to the speed of sound, but it needs to stay below 13,000 feet. So we have to design this rocket here to stay below 13,000 feet, but still reaching high speeds, which is a difficult task. So we can't make this too light, but we can't make it too heavy. So it's a difficult task to balance these two. But last year we launched a total of 4 rockets, and they all went up beautifully. And we also recovered some, which almost hit the speed of sound, which was a really cool experience to watch.
Very good. Monty, you want to do your part?
Hi, I'm Montgomery Hughes. I am a senior in the Alamo Heights Rocketry program. I joined my sophomore year, which is a little late to a lot of these people, but I think I've pretty much caught up. I plan on going to Colorado School of Mines with a major in engineering, mechanical engineering. And this year I am working on the nose cone, which is this right here. This isn't ours, but we're going to build one that is very, very similar to this one. It's a difficult process. It requires a bunch of complicated mathematics to form equations. Traditional rockets you might see with just a straight cone that's at an angle, but the rockets that we build nose cones that are designed to minimize drag to as little as possible to allow our rocket to go as fast as possible, which is why you see that shape here. That curve is called a von Karman curve, which we work a lot with to perfect our nose cones.
What material are you using to fabricate it with?
This year we're using carbon fiber, which is a super strong, super light material that is difficult to work with, but we think we can, which is cool. Something that I thought was interesting is just the size difference between these nose cones. You can see the purple one. This is the nose cone, stops right here, and our nose cone is, it's 3 times the size of that one. It gives you a perspective on the size difference of the rockets that we're building this year compared to past years. And that's a big reason why I chose nose cone, is just because it's a huge part of the rocket that is just, it's fascinating to me. So.
Watch the time.
Okay. Jack?
Hi, I'm Jack Weiball. I am a senior at Alamo Heights, and I am part of the senior rocketry class. Last year, I was in the nose cone component, which was my friend Monty over there. He just presented that. But the nose cone's goal is to minimize drag, and although it may seem like a very simple shape just on the top of the rocket, there's actually a lot of complexity that goes into the making of it. So it's very time-consuming, intensive, and it takes a lot of dedication to get something like that. But this year, I'm going for a avionics component. So we have altimeters that have to deploy parachutes. And what I've done with my teammate is create a compartment within the rocket that's sealed by 2 aluminum bulkheads and O-rings. So when the explosives go off to take the nose cone off, we have our altimeters inside that compartment, and they're unaffected by that sudden pressure change. And the whole goal of altimeters in the rocket is to make sure that we can recover it and get data from the flight. And next year, I'm hoping to go to maybe Texas A&M or Colorado School of Mines for aerospace engineering, or maybe some other type of engineering. But that is my goal right now, and I am enjoying being in this rocketry class.
Thanks. Clay?
Hello, my name's Clay, and I'm a senior in Alamo Heights rocketry, and last year I worked on the recovery system for a rocket similar to this one. Unfortunately, I like to pride myself with saying our recovery system worked a bit too well, and it deployed both of our parachutes at once and causing it to drift off to who knows where. So hopefully one day some rancher working on his farm or wherever will find it and bring it back to us, but who can really say if we'll find it again. But I'm sure if we do get that data back one day, I know we achieved our goal of exceeding the speed of sound. And this year I'm working on an injection system. So like Eric mentioned, it's this little piece right here, except ours is honestly a little bit longer, but kind of similar in its design and what it does. Obviously it's an original design by us, and we create our own. So again, this injector is responsible for keeping constant flow of nitrous oxide into its fuel grain and keeping a nice flame going. And I'm still not sure where I want to go to college, but I know I want to pursue my love for aerospace engineering.
Thanks, Clay.
Thank you.
Ben, you ready?
Hi, my name is Ben Fry. I've been a part of the rocketry class since the beginning of my junior year of high school. I'd like to pursue my career in aerospace engineering or mechanical engineering later on in my life, but I have not currently decided where I would go to college. Like Eric, I'm part of the airframe component, and so not only are we creating this much larger fuel tank, we create our own weld caps, which is this object right in front of me. This weld cap goes on the bottom portion of our fuel tank where we weld it to it, and these sets of holes are where we bolt it to the bottom portion of our rocket. Now there's some holes on the top, and this big hole right here in the middle, that's where Clay's injection system will be. And then these 4 bigger holes will be some fill tubes like this. Will fill our fuel tank with the nitrous oxide that we use as our primary oxidizer in our rocket.
Thank you. Anna?
Hi, my name is Anna Gracia, and I've been a part of the rocketry program for 4 years. Last year and this year, I've been a part of the avionics component, which Jack kind of touched on it a little bit, but it's basically just this electronic system that records the velocity and altitude of the rocket while it's flying, and then it also deploys the recovery system. This year, our recovery system, and it was also like this last year, it is a dual deployment system, which means there are 2 parachutes that are deployed at different altitudes when the rocket is flying. And so our whole job is to program our electronic system to what altitudes we want them to be deployed at certain times.
And what kind of data will you guys be recording?
So when we get the data back after we recover the rocket, we will see how fast the rocket went at certain altitudes and how high we went.
Excellent. Yeah. Brian.
Hello, my name is Brian, and I worked on the nozzle this year. What this does is reduces pressure-induced drag from our body tube in a rocket, making it go faster. I've been on the program for 4 years. Last year, I worked on the nose cone, similar to this one as well, with another partner. And what I think this program has given me at least is not the
That's all right.
It has given me the chance to not only grow as a person, but also as a partner, and the diversity that this program has, encourage others to be better. And I like a quote that Mr. Lang has saying, "It's not if, but when things go wrong." We learn, maybe last year we didn't recover a rocket, but we learned from that, and we can pass that on to previous years to better improve.
Thanks, Brian.
Thank you.
Well, all you students, how many of you are going to continue working on rockets and possibly go to work as a rocketeer? All of them. We're developing a whole new group.
Yeah, a whole new generation of innovators.
I was wondering, where do you, the components of these rockets, do you design them?
Mm-hmm.
And then who built them?
Most of the components, we build over 90% of our own components in our own shop. And that's one of the things that makes our program unique, is that we have a complete machine shop at Alamo Heights.
Oh, you do?
Yeah, we do.
So then you get to work with another department?
Well, it's mine.
Oh.
It's our shop. We're not working with other people. It's actually, I teach them how to do that as well. So when they come in, it's one thing to design a component, but it's a completely different thing for you to actually go into the shop and build that component. And that's where there's a real disconnect with a lot of engineers, is they don't get that opportunity to build something. And so they're really theory-based. And so when they do try to go to build something, the people who are building it go, I can't build that. Whereas these guys...
they built those?
Yep. They build these components that you see up here. They actually fabricate it themselves, yeah.
That's amazing. Do the other schools that offer the rocket course Do they do the same thing?
Not most of them. I mean, there's a couple that are now bringing more and more of the components on themselves, but we've been pretty much the only school up until recently that fabricates our own components.
The 4-H Club has a rocket program. Are you familiar with that?
No, I'm not.
I thought that was kind of interesting because they, where is it? Well, anyway, they do have a rocket program, and it's, now your program, you have to be a student at Alamo Heights High School. Are there any programs that are available for somebody that doesn't have it at their school or is not in school?
Not that I'm aware of. Most of them are school-based. There's some really like great programs out there. One of them is called TARC, which means Team Across America Rocketry Challenge, and that's open to junior high school students and high school students across the country. And normally what that is like a rocket that they're carrying an egg to a certain altitude and bringing it back unbroken within a certain period of time. And it's a wonderful challenge, and it's a wonderful program, but again, it's not something that you could do individually. Now, once you get out of high school, there are several different rocket societies out there that
in San Antonio?
Not just in San Antonio, across the country, that they have different levels that you can rise up to, from level 1 to level, I believe, 5. And each one of those levels is maybe a little more altitude. Of course, recovery is very important. Recovery is the hardest part of doing this. It's one thing to make the rocket go up, but bringing it back down again, that's really hard.
What's the best email for someone to use to find out more information?
I'm not sure off the top of my head. I would have to look into that for you and get back to
you. What about you?
Sure. I mean, my email address at Alamo Heights is clang, my first name and last name, at ahisd.net.
And you
absolutely. I'm always willing to help people.
You're going to answer the questions of you millions of listeners and viewers. Well, I see we're running out of time. Colin, thank you so much for being with us. Thank you, students. You're fantastic. You're all rocket scientists. And the Green Connection next month, which is March, we're going to do something. We're going to bring back the old St. Patrick's Day show from last year because we don't have the room for the musicians we had. And we have one group from Ireland that's going to be here. So watch the rockets and watch us also next month. Thanks for watching. Have a great green day.